Hello students, and welcome to our first video in Unit 4 where we're going to solve equations with variables on both sides. Now this is definitely a review from your math past. Example 1 says we're going to solve and check this equation, 5x minus 21 equals negative 2x plus 28. And I know your instinct is probably to jump right in and use algebra, but we're going to think about doing this two other ways, maybe two ways you haven't thought about lately, and then we'll come back to the algebra. So let's take a look at, and you know this very well from me from our former lessons, let's just take a look at good old granny style. Granny style means just guessing and checking because Granny doesn't know algebra. So if Granny were doing this problem, she would know that she has to find a number that would fill in for these two x's, and we would, if she gets lucky on the first guess and gets it right, then the two sides would be equal in the end. So my favorite number in the whole wide world is 8. So if I'm Granny, I'm going to let x be 8 and see if that's the answer. So if I try that, I would have 5 times 8 minus 21 set equal to negative 2 times 8 plus 28. So if you have 5 times 8, of course that's 40 minus 21. And here we would have negative 16 plus 28. So 40 minus 21 is 19. And negative 16 plus 28 is 12. So unfortunately, Granny style using x equals 8 is a total bust. But you can definitely sit here and let x be lots of different things if you had all kinds of time, and eventually you would find the magic that makes these two sides equal. But for solving equations that are a little bit more complicated, it's not the easiest way to do it Granny style. So the next way I want to show you is on your TI-84. Yes, you can actually solve equations on your TI-84. So check it out. Grab your TI-84, bring it on over here. And you're pretty familiar with this because of the work we've previously done, but I'll guide you through it pretty slowly at first. So what we're going to do first is we're going to press down y equals. So go ahead, press down y equals. And if you have any old stuff in there, you can go ahead and delete it. Now, in y1, right, we're actually going to type the left side of the equation. Everything that comes to the left of the equal sign. So let's go ahead and do that. 5x minus 21. Enter to store it. And in y2, we're going to type everything on the right side of the equation. So that would be, or the right side of the equal sign, that would be negative, and make sure you're using negative, not minus. The calculator doesn't like that. Negative for negative 2x, negative 2x plus 28. Okay. Now, I don't know what my window is set at right now. I'm going to go ahead and hit graph and see what happens. Okay, and as you can see, I'm seeing one line here. I'm guessing this is my first line because if this is the y-axis and my y-intercept is negative 21, I know I'm going to be hitting the y-axis down here at negative 21. Now, the negative sloping line is starting to show itself right here, but the problem is its y-intercept, or its b, is 28. So we need to go way, way, way up the y-axis to see where this is crossing at positive 28. So we need some definite window adjustment. So let's press down window. Now our default window is set right here. This is what we usually just default to when we're graphing, unless we've got issues that have to make us adjust the window. So I'm going to leave the x's intact. I think they're fine. It's the y's I want to stretch. So I need to go as low as negative 21. So I'm going to stretch a little further and maybe go to negative 25. And I need to go as high on the y-axis as 28. So maybe I stretch to 30. Now let me graph and see if I see two lines that intersect. Yes, much better. So now the point of intersection is going to be where these two lines are indeed equal. And you should remember from prior lessons how to find a point of intersection. We want to calculate. Right here in blue, above the trace button, we want to calculate. So let's hit blue second. Let me move this up a little bit. So we're going to hit second, trace, which is calculate. We are going to arrow down to number 5, intersect. You can also just press number 5, hit enter. And here come our prompts. First curve. You see my cursor blinking here on the first line I typed in, so that's good. I'm going to hit enter. Second curve, it jumps up to my other line. That's good. Enter. And now it wants me to take a guess on the point of intersection, so I'm going to arrow my right arrow down to the point of intersection. I'm guessing they intersect about right there, and I'm going to hit enter. And here we go. Oh my goodness, look how close I was, granny style. The real x is 7. 7. So the real answer to this equation is x equals 7. So if I would replace a 7 right here and a 7 right here, we would get a smiley face. Let's go ahead and do that. So if I make this a 7, let me just write over top of this. And if I make this a 7, let's see what happens. 5 times 7, that makes this 40 a 35. And negative 2 times 7 makes this a negative 14. And so 35 minus 21 is 14. And negative 14 plus 28 is 14. And with x equals 7, we've just turned that frown upside down. And what's cool is when x is 7, you see how both sides come out to 14? That's what your calculator will show too. See? When x is 7, y is 14. So that's pretty cool. Hey, Rocco, zip it. I'm making this video from home. Okay, so that's the first one. Now, I will show you the algebra. So algebra is the good old method that you have been doing. Rocco, Rocco, come here. You're being rude. Come here. No more barking on this video. Okay, so what we're going to do here is because we have an x on the right side and the left side, I'm going to go ahead and add 2x to both sides. Like such. 5x plus 2x, of course, is 7x. I'll bring down the minus 21 equals, these knock out here, and I'm just left with 28. Then I want to join my numbers together, so I'm going to add 21 to both sides, which in turn is going to give me 7x equals 49. And my final step, well, here you can see 7 times 7 is 49, so you know x is 7, or you could divide both sides by 7 if you want to use algebra, and you also get x equals 7. Excellent. So that's example 1, done 3 ways. Granny style, TI-84, algebra. Okay, in the next one, right here, example 2, why don't we do it in reverse order? Let's do algebra first. Good old algebra. So looking at this, it looks complicated because we've got negative 3n minus 2 times the quantity n plus 4 equals negative 6n minus 5. So if we use algebra, I guess the first thing we're going to do is distribute this negative 2 to the quantity as such. That will give me negative 3n minus 2n minus 8 equals negative 6n minus 5. Here on the left side, I'm going to combine like terms. Negative 3n minus 2n will give me negative 5n minus 8 equals negative 6n minus 5. And now it looks very similar to example 1. I'm going to go ahead and add 6n to both sides so that I can knock these off and combine like terms over here. Negative 5n plus 6n is just 1n. So n minus 8 equals negative 5. And now, final step, add 8 to both sides. So we'll add an 8 here, we'll add an 8 here, and it looks like I'll get n equals 3 using algebra. Okay, let's check it on the TI-84. Let's check it. So bring your calculator on back. Let's hit y equals. Let's clear out example 1. Now the cool thing about the TI-84 is even though this left side of the original equation is looking kind of messy, you're going to plug it in just how you see it, parentheses and all. So I'm going to do, and I'm just going to use x's for n's because the calculator defaults to x, that's fine. So we've got ourselves negative 3x minus 2 times the quantity x plus 4, close parentheses. And that's the entire left side. Hit enter. The right side, negative 6x minus 5. And I'm going to go ahead and hit graph. I'll deal with my window later if I need to. Okay, so we have two lines here, and it looks like they're intersecting about right here. Let's see if they are. I'm going to hit second trace to calculate. Number 5, intersect. First curve, I hit enter. Second curve, I hit enter. And my guess, I'm going to pull down here to where it looks like they're intersecting. Hit enter, and lo and behold, there it is. X is 3. X is 3. So the TI-84 is confirming my algebra. Great. So I'm just going to write x equals 3 here, or n equals 3. And then, of course, granny style. Would I have wanted to do this granny style? Absolutely not. But granny's a good check. So now knowing that n is 3, let's go back and plug 3's in here, here, and here. So this will be negative 3 times 3 minus 2 times 3 plus 4 equals negative 6 times 3 minus 5. And so we check it. So negative 3 times 3 is negative 9 minus 2 times 3 and 4 make 7 equals negative 18 minus 5. If I keep going here, that would give me negative 9 minus 14 equals, let's see, negative 18 minus 5 is negative 23. And then negative 9 minus 14 is negative 23. So we've got equality. So that's a good sign. That's a smile. So 3 ways of solving equations. Now, this last one, example 3. Let's finish up strong with this one. It says a cell phone carrier offers 2 payment plans. The first plan offers a monthly fee of $40 and a charge of 30 cents per minute. The second plan offers a $25 monthly fee and a charge of 50 cents per minute. Write an expression for the cost of each plan if you speak m minutes per month. Okay, so based on Unit 3 and the work we've done with linear equations, this part should be pretty easy. So let's write the equation for the first plan. So my equation for the first plan, and feel free to pause me if you need to try this on your own. I would say y equals 30 cents per minute, so 0.30 cents per multiplication, 30 cents per minute, 0.30 times the minutes you speak, plus $40 monthly fee. You could also make this an X if you want to. And you could or if you keep it with money or minutes, you could do C for cost, like the cost equals 30 cents a minute. The second plan would be written then as y equals, that's the cost, 50 cents per minute plus the base monthly fee of $25. So those would be my 2 equations. And then the question in letter B is, for what number of minutes are the costs equal? Okay, so if Granny were doing this, she'd have to figure out some number. You know me, my lucky number's 8. Maybe she takes 30 cents a minute times 8 minutes plus 40, and 50 cents a minute times 8 minutes plus 25. If she gets the same cost, then she's got it. It would be 8 minutes. If I use my TI-84, let's use the TI-84 and see what's going on here. So let me pull this over here. So if I have y equals, clear, delete this old stuff out. Let's type in the first equation, 0.30x plus 40. Second equation, 0.50x plus 25. If I go ahead and hit graph, let's see what comes up here. See the first line there? Comes the second line. Where is the second line? Let me go back to y equals. Well, it looks like I typed them incorrectly. Now I have a y-intercept of 40 and a y-intercept of 25. I'm wondering if I have to stretch my y-axis up higher to accommodate this y-intercept of 40. Let me go to my window. Indeed, look, my old window from example 1, I guess it was, has my y max at 30. Let me stretch that to 50 so that I accommodate the 40. And maybe my scale now, maybe I don't want to go by 1s because I have such a stretch. Maybe I go by 5s. Let's see what that looks like. Ah, much better. Now I see 2 lines. The only problem is I don't see 2 lines that intersect. So I guess my 0 to 10 minutes, which is what I currently have this set, 0 to 10 on my domain, I guess the number of minutes I'm talking so that the 2 plans are equal is a little bit more than 10 minutes. So I've got to adjust my window again. So let's hit window again. Let's take our X max. Oh boy. Let's take it out to 100 minutes. Let's go crazy. And let's scale it not by 1s because that's a far stretch. Let's go by 10s. Let's see if we see a point of intersection now. Well, we're getting there, but now it looks like the point of intersection is even higher up. So I'm going to have to stretch my y again. So window. All right, let's go higher on the y. How about we go to 100 on the y? There we go. Now we got a point of intersection. You just have to play with it. So this is our point of intersection right about here. So I'm going to do second calculate, intersect, first curve, enter, second curve, enter, guess, I'm guessing they intersect over here somewhere, right about there. Okay, so I'm getting 75 minutes. So Granny might have been here for a while till she guessed that 75 minutes was the answer. And it looks like at 75 minutes, both plans cost $62.50. We can check that in a second. So by the TI-84, the number of minutes that need to be spoken for both plans to be the same is 75. Now, Granny, we can go ahead and check it. If we check the first plan, we would have y equals 30 cents a minute times 75 minutes plus 40. Let's check that out. So if I take 0.30 times 75 plus, is it 40? Yeah, plus 40. There it is. I get $62.50. That's the first plan. Now if I check the second plan, I've got 50 cents a minute times 75 minutes plus 25. That would be 0.50 times 75 plus 25. That's also giving me the same price, $62.50. So if you speak 75 minutes, it doesn't matter which plan you choose, right? Now, the last method, of course, would be algebra. Let's take a look at algebra. So what I see here is a system of equations. And we've already studied systems of equations. we sort of already solved the system by graphing on the TI-84. Another way to do it would be substitution or elimination, but I think I would do substitution. And the reason is both equations are solved for y. So if I use the second equation and call this my stuff, then I can plug this stuff up in the other equation where the y is. Y is equal to this stuff, so this stuff can replace that y. So that would give me 0.50m plus 25 equals 0.30m plus 40. And now it's kind of like examples 1 and 2 again. I could subtract 0.30m from both sides. That would give me 0.20m plus 25 equals 40. I could then subtract 25 from both sides, which would give me, let's see, 40 minus 25, that is 15. And then I can divide both sides by 0.20. If I take 15 divided by 0.20, I get 75. So that's another confirmation that the answer to this is 75 minutes. Very cool. Okay, so this is solving equations with variables on both sides, but I'm adding a twist because I'm adding the TI-84. I'm just cross-checking or guessing and checking with Granny style, and that gives you a lot of options. Okay, thanks for watching.